Lithium electric tool mini cordless electric chainsaw. Let me get this out of the box and describe, well, what's inside. Let me show you that it's like an unboxing. That's nice. I don't do many unboxings. Instructions, written in Chinglish. Very odd instructions. It's like someone deleted all the spaces and then added them in random positions. What we have in here is an unusually light charger. I tried opening this already on a live stream recently. It's very hard to open. It's unusually light. It's really bizarre. We have a spare chain, and it says it's an expert chain, but it also says angel of chain, angle of chain, and angel of filling, angle of filing. It comes with two rechargeable lithium batteries, which are apparently, possibly Makita type clones, rated 21 volts, they say. It comes with a pair of gloves to stop you chopping your hands off. That's not going to work. And it comes with the handheld chainsaw. Right, tell you what, let's get this out. I've just knocked over some bottles of flux and stuff like that, but I also have a bottle here. I had a bottle here, I've misplaced it, of chainsaw oil, because I'm going to oil this thing, and then I'm going to take it out and we're going to chop something up. But let me just show you initially. Let me just focus down on here. That's better. Let me just show you. I'm going to connect this, but I'm going to be very careful because this thing has no safety interlocks. There's nothing. It only, as soon as you pull this trigger, this chainsaw blade is going to start running. So let me connect a battery to it and give it a quick zap. There we go. Perfect. Right. I'll tell you what, I'm going to take the battery off now for safety reasons. And I'm going to take it outside, oil it, and chop some wood, and we'll see how well it cuts wood. Old dry wood. Cuts okay. Fresh green wood. Also cuts okay. Not bad. Right, let's explore. So the only thing that wasn't supplied with this, you got some basic tools and a replacement chain. The only thing that wasn't supplied was chain oil for chainsaws. And this oil is a very sticky, gooey oil. It's designed to actually cling onto the blades and not get sort of thrown off or basically spread onto the wood. Ultimately it does. But it doesn't have an oil feeder, so you're going to have to oil it. I don't know if they recommend that. I didn't read the instructions. Well, there we go. The chain. Yep, right, I'm not really sure how you'd specify. I'm not really used to changing chainsaw blades. I usually just buy them for specific models. I shall investigate this. But it's a nice sharp chain, and as usual with these things, you can just sharpen them if you have the correct tools, which is kind of essential for chainsaws. The batteries are quite heavy. The batteries weigh about 310 grams each. The charger weighs 69 grams. The unit weighs 743 grams. When you add the battery on, it comes up to just over a kilogram at 1053 grams. This is a safety guard. You've got two screws on the front here. One is for adjusting the blade tension. One is for this safety guard. Now, I'm guessing the safety guard is for two things. I guess really it's an anti-kickback guard to try and stop it carving up your face is the first thing that comes to mind. I should have put that on before I used it, but I didn't. Let's take something to bits. I shall take this apart first. So let's go into this. You undo the cover over the chain mechanism. And if you undo this screw here, this is a double-edged, double-sided screwdriver it supplies. I know this because it popped apart when I was taking it initially. There is a screw down here, and when you're actually setting this up, this moves this pin to actually slide this bar backwards and forwards. It tensions the chain. The chain should be tight enough that it's not taut, but just tight enough that you can just pull it and it's got a little bit of slack coming out there. Too tight and it puts excess wear on this and the chain. Too loose and it may actually skip right out of the actual chain bar. That gets adjusted by this little screw here, which I shall loosen off now. And when I loosen it off, that should loosen it enough that I can then lift the chain bar off, and the chain is just driven round by this sprocket. There is the mechanism that slides backwards and forwards. Very simple. Don't do what I did and tighten that one thinking that was the tensioning system. It's not. Let's go into this a bit deeper. Anything else going to drop out here? Probably. It is held together by Torx screws, which I've already pre-measured, so to get the correct screwdriver. Not sure if all the screws are going to be the same length. It'd be really nice if it was. It's always a good thing when the screws are all identical length, but sometimes they're not. That's a good start so far. The lack of safety is a concern in this. If you have one of these, I strongly recommend taking extra precautions, wearing gloves to at least provide some protection, thick gloves, but making sure that when you're not using it, take the batteries out of it. If you had this in a toolbox and you reached in and pressed that button down, even though it's got a fair decent amount of spring to it, if it started off, the blade would make short work of your hand, which is not good. So far all the screws have been the correct size, the same size. This is good. This one is recessed deeply, which is a bit annoying, but that's alright. I have my deep Torx to get that out. And this should be the last one. It mentions in some listings that this is a brushless motor. Kind of skeptical about that, but you know what? Let's find out. Ooh, does it come apart easily? Have I got more screws to take out? Let's loosen this off. Is there anything I'm missing here? Have I missed a screw? I don't think I've missed a screw. I think it's just tight fit, which it should be. Maybe I should take that. Oh, no, there it goes. It is not. It is not an electronically commutated motor. It's a plastic gearbox. It's got a standard variable speed control system with a little heatsink on the outside. It'll be super mass produced. Can I get this out further? I'm going to need another screwdriver bit to get this out. Is it going to reveal much other than the fact that this is a plastic gearbox? I suppose, really, in the spirit of Ave, I should be going deeper. Oh, it's actually the same bit. That's nice. Again. I looked, when I saw this online, I was very skeptical about it. I looked at reviews on YouTube of people who had bought these, and they were all raving about how much stuff it cut. I think ultimately that the plastic gearbox does allude to a certain disposability. Is this going to come out? Anything else holding it in? I don't see anything else holding it in. Is it latched in some way? Is it some spring-loaded mechanism? I shall push in the front. Or has all this has been added afterwards? And I don't think there's a grub screw. I think this has been pressed on. I don't know if this is going to come out then. It looks as though this wheel has been... Right. Give me one moment. I'm just going to actually, you know, let's not pause. Let's just try and grip that. See if that's going to unscrew. No, it's just rotating the whole thing. It is just a gearbox, but you know, I feel the need to take it out. One moment, please. And the secret is apparently this little circlip that was round that, which is now off, letting this lift off, and now the gearbox drops out. Oh, really, that's it? Not much gearing. It is this little direct drive from the motor shaft onto this, which is going through a fairly deep bearing to the back of the unit for extra stability. There's really not much in here. Ave would be analysing all the metals and things like that. I'm not going to analyse all the metals. I'll analyse the electronic stuff. The speed control will be a standard speed control. Right, what's next to open up? Now I've taken that to bits. Right, tell you what, I'm just going to pause while I put this together just so I don't mix all the hardware up. And then we'll go into the battery packs. One moment, please. Right, battery time. But before I go into the battery, things worthy of mention, there's a 100 degrees Celsius thermal cutout on the side of this. So that's quite interesting. I hope it's a self-resetting one. I think it is. But it's just if you've got one of these and you're using excess in the garden, it cuts out, it may be that. Also a potential point of failure. I'm going to put this down the ground now and make sure I don't smash my feet into it. Let's take one of the batteries apart. It feels hefty. This doesn't always mean anything. It might be full of metal. Hopefully it is full of metal, battery metal. It's interesting to note that you can get 21 volt ones, you can get 48 volt ones, 56, and well, this charger actually says it goes from output 21 volt to 98 VF, 1 amp DC. By 98 VF, it means fake, because this is just a 18 volt charger effectively. This probably has 5 cells in it, because that's what you'd typically find, an 18 volt battery pack with 5 cells. And a charge control circuit board, well, a protection circuit board. Right. One moment, please. I'm just going to take a picture of this and explore it, try and find what the chip is, and we'll analyse the battery. At this point in time, the battery says INR, or 18650p, 2000 milliamp hour. That would be quite respectable, actually, if it was 2000 milliamp hour. Interesting stuff. One moment, please. And resume. Very interesting. The chip it's using is a CM1051, which is a 5-cell protection pack. There is the output to the actual tool. Because the charging port is in the back here, you basically plug into this little charge port. But the output for protection of the MOSFETs, it has a back EMF diode wired across those 2 pins. I wonder what that was initially. The MOSFET here is the discharge MOSFET. That's used to basically shut the battery pack off when the voltage is too low, or potentially it will monitor for an overload situation as well, where the voltage, it measures the voltage across this MOSFET, and if it gets too high, it detects that as high current overload, and the chip will switch it off. There is the option for putting 2 MOSFETs in parallel. I was thinking, so where's the charge protection? Well, the charge protection is this tiny little MOSFET here, because the charge current is somewhere between 500 milliamps to 1 amp. So from the charge port, we've got a connection via a diode, and then over to the negative connection via the MOSFET. So the chip schematic, it gives a couple of options for the wiring. It gives one where you've got the inverse series MOSFETs for controlling charge and discharge, but this is the circuit they've used down here, which is where there's 2 separate MOSFETs used. So only the big MOSFET is needed to switch the current out, and the charge MOSFET is that tiny little one. But everything else is more or less textbook. There is the facility in that chip for a temperature sensor, which is bypassed by this little resistor that's been soldered across that position, so they're not monitoring for a temperature situation in the pack. Anything else worth mentioning here? Not really. It pretty much fulfills the thing. Each cell is monitored via its own resistor and capacitor, just forming a sort of like a simple decoupling circuit, so that you get a fairly smooth, consistent input where it monitors that voltage. There's no balancing at all, as there is on even posh battery packs. All it does is, if, say for instance, that something had happened, a pack had got wet. This seems to be a common thing. And it had caused, a pool of water had caused this battery to go low, this lithium cell to go low. If these ones are, say, fully charged 4.2 volt, and that one was way down low, it was almost to the point of cutting off, then it won't balance them again. If you put that on to charge, it will terminate on the batteries that are already full, but if you plug it into the tool, it will terminate on the one that was almost discharged already. So you'll end up, the battery pack just doesn't have much capacity. The answer there is, if it's not damaged, if it's not got a bad cell, is to measure the voltage across all the cells individually, find the one that was that was low, and just gently bring it up to the same voltage as the other ones, and equalize the voltage accurately to 1/10 of a volt across them all. And that will restore the battery pack. If it loses capacity again, suspect that one of the batteries is damaged, and it's time to dispose of it in a controlled manner, discharging all the cells completely before disposing of it in a suitable place. In the contents of lithium cells, it's actually a mixture of copper and aluminium and graphite and lithium iron cobalt, I think it is, all fairly inert materials. It's the energy they store that is the danger. This is one of the things the battery manufacturers all distance themselves. I should make a video about that. They distance themselves from people using these cells out with things like packs. 18650s are designed for use in packs, and they basically put a bulk disclaimer out altogether. It must have been the Battery Manufacturers Association organised it to basically say, if you use these individually, we're not responsible if they blow up in your pocket. When you short them out in your keys, because that's what was happening with the vapors. So that's it. Really not much. This little tiny MOSFET for charging, this big one for switching the output with the option to boost it up, and add a thermal sensor. It's a typical battery pack, to be honest. Right. How am I going to get into this little thing? Because this, I'm going to have to use brute force. I have spudged this unsuccessfully, to the point I actually bent the spudger a bit. I can get the spudger in like that. I can slide it along, but there's no obvious screws. I reckon there's glued pillars in here, so I'm going to have to get destructive. I may have to get Abe's hammer out and just give it a little tappy tap tap and see if I can get into this. One moment, please. The Ave, hammer of ultimate knowledge, did free the truth. The truth is now free for us to explore. Interesting case. The case was kind of held together with pillars. In reality, it's got clips here, 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 and here, but with supporting pillars to actually make those clips hard to part. So once you force this together, it's actually extremely hard to get apart. For reference, the case is called an XY207. Not sure who makes that. It's quite a good case. It's very, very robust. Stuff ricocheted out. I think it was just an insulation plate. There was also bits of foam holding this circuit board in place. The circuit board has the mains voltage switch mode circuitry on this side, driving this transformer, what looks like a class Y capacitor but isn't. It's part of the snubbing network. There is no class Y suppressed capacitor. And then the output side, it's really just a voltage monitor, an LM358, to monitor the voltage to actually light this LED to show it's charged. It doesn't, the current regulation is simply the energy capacity of this inductor when fully charged from the primary side, the flyback circuitry. And then when this side turns off and that dumps, it puts out a portion of energy. So the current limiting is ultimately in the transformer. Let's take a look at the circuit board. We have the incoming supply, which has a fusible resistor, 4.7 ohm, leading to a bridge rectifier, and then there's a smoothing capacitor. We've got the FM3783GA chip, and it just has a support components. It has a snubber network. It has the current sense circuitry. It's got feedback circuitry, and it's also got bootstrap. I'll show you this on the drawing. The bootstrap is consisting of this diode here and this little electrolytic capacitor here. On the output, we have the rectifier diode and smoothing capacitor, not very big. And then we've got the LM358 to actually monitor the voltage and just switch the LED. That's all it does. Not too much to say about that. Horrible contrast of circuit board. This is much better. Let's take a closer look. I didn't draw the op-amp in. Maybe I should have, but I didn't. Incoming supply, 4.7 ohm resistor. There's the bridge rectifier. It's a discrete single package bridge rectifier. There's capacitor, 6.8 microfarad. A few components missing, few components added. The bootstrap circuit for this chip, the way it powers itself is initially current flows from the positive supply rail through this 1 megohm resistor to this capacitor, charges it up. Once it's charged up to a suitable level, this then starts. Once it's started, if everything is working, if the output is not short-circuited, it also, as well as powering the output, it also powers via this diode. It keeps that capacitor charged up, and that's how this chip powers itself. If something goes wrong, if this gets shorted or it can't actually make up that power supply, if this power supply goes wrong as well, this capacitor, it will do that blink, blink, blink hiccup thing because it's repeatedly trying to start and failing to start. When it turns on, there's a MOSFET inside that the current flows from the positive through the primary, down through the chip, and then through these current sense resistors. There's 1 ohm in parallel with 9.1 ohm, which means it will just be, the total value will be just slightly less than 1 ohm. The lowest value takes a precedence here. And that measures, that basically regulates the amount of energy put into the transformer. There's a feedback circuitry to show that things are good. Basically, they've set a resistive divider here, 15K and 7.5K, going to the feedback, which also lets it monitor what's going on in the transformer. That is about it. So this thing just blindly just pumps, energizes the transformer, and then when it turns off, the field collapses, and that's when the current goes through that diode to the output. So it puts controlled portions with magnetic isolation of energy through that. The one other thing worthy of note here is this 100k in parallel with a 1 nanofarad capacitor and this diode from the primary. What that does is when the transistor turns off in here, there's an initial quite high spike. Before this diode can start conducting, it basically just nips off the peak of the EMF, the back EMF that could otherwise, the high voltage could damage this MOSFET. So it diverts it to this capacitor, and this little resistor here just keeps trickle discharging that capacitor just to basically take a controlled chunk off that back EMF spike, but without actually shunting too much energy that's needed going through here. After that, it basically has an op-amp driving the LED. I'll just draw this in roughly. And the op-amp monitors the voltage across a resistor going to the output. Is that resistor in the positive or negative? It's actually, I think it's in the negative. So it actually monitors the voltage drop across that resistor, and if it sees a significant voltage drop, it knows that this battery is still charging. But if it sees the voltage equal on our side, it will signal to this op-amp that there's no charge current going out, and that's just when it says charged. And it does that trick. There are two LEDs. Let me bring the drawing in again. There are two LEDs in this package. One is powered continually, and the other one, probably the green one, and the other one, the red one, is switched by the LM358. And instead of turning the green off, all it does is it switches the red one on, and it swamps the green out to show that it is charging. And when it has charged, it turns that red LED off and the green light shows, even though it was lit all the time in the background. So what are my thoughts on this thing in general? The batteries are typical of a battery pack for a tool. It's not bad. Good, decent, springy contacts. Good, solid contacts. I guess it is based on another brand's battery. Interesting, the charging port is built onto it. It does have the protection. It has the option for you to upgrade that protection with another MOSFET, or they'd probably have to be matched. And it does have both discharge protection. It has charge protection with full monitoring. I should go brighten this image up a wee tad. There we go. It's not bad. It's a generic package. The case for the power supply snaps together very tightly to the point it was very hard to get apart. The tool itself, it has a plastic gearbox. That's no great deal because the main components here are steel. The bearing here, presumably a sleeve bearing. The motor looks beefy. You can't really tell how well it's going to last. The little regulator will instantly disintegrate. It will be full if I try opening it. It will have a minimum number of components just for the variable control using pulse modulation, and a little battery connector that slides in. You know, it's almost worth actually getting something like this just for the batteries, the charger, and this sort of bit down here, the connector, because then you can tap into the battery. And you could just make a little power supply. It uses these. It's surprisingly good, I shall say. How long would it last in continuous use? I'm not really sure, but the construction in general looks pretty typical. I guess that's just what happens. You mass produce things. The batteries look acceptable. The construction of the unit looks acceptable. It just seems like a fairly decent generic unit, just lacking that safety that is kind of essential, just that little double function that, you know, you have to make a concerted effort to push that button. That's the biggest weakness. It's a fairly stiff, springy plunger, but there's still that risk that, you know, particularly if this got into the hands of kids or something like that, that you could hurt yourself, because chainsaws are ruthless. They're not very friendly to hands and faces and body parts at all. But other than those things, that safety issue, it seems okay.